Okay. So typically, when we've been writing code in MIPS, we've been actually just writing code like that, right? I mean, which is actually fine. It's correct. But a better way of doing it would be to define, essentially tell the the assembler, which will take this one and convert that to machine code, that this is part of the code and it's not part of the static data, which is really the global arrays and the global variables that we talked about in the last video. Now, if you don't put anything before this, it'll assume that this is code and it'll run just fine. But if you have global variables and global arrays that you want to define, then you would have to actually do something that looks like this: dot text. And dot text is going to say, in fact, I never read this, but it says subsequent items will be instructions, and they're going to be stored in the text, which is really the code segment uh, in that chunk that I showed you, in this chunk of space that I showed you. When you say dot text, you're essentially telling it that everything after that is going to be should be stored in the code. Now, again, if you don't do that, it'll just use, if you don't have text, it'll use the code for anything that you have. But you do need to start using these directives. That's what they're called, directives, when you have a global variables or arrays that you want to define. So if you have a global variables or global arrays, those would be under the .data directive. So anything here is going to go to the static data section. I wonder if that's what it says. Let me see. Subsequent items stored in data segment. Yeah, I mean, data segment in this case is going to be the static data. So if we were to go back to what we had here, so we had a variable and we had an array. Now those names for those global variables and global arrays will become labels. That's how you convert global arrays and global variables to MIPS. So you would have to create a label. So just like we've done labels before, right? Labels were like that, L1 colon or after colon. So this one would be a label. So we would say global variable colon, like that. And then you would have to write something after that depending on what you have here. If you have an integer, which is a word, integer is 4 bytes, so that's a word, you can actually do dot word like that. And you can see it says, I actually never spent time to read this, but let me do it here with you. Maybe that'll be something that you can use when you write code in the simulator. It says stores the listed value as 32-bit word on word boundary. Okay, perfect. You don't need to worry about what word boundary is. It's going to store 32 bits, which is really 4 bytes, and that's really what we want. So you would say dot word, and then you would assign the value, which is 10. So this code is going to be translated to what we actually talked about before. It's going to be translated to this, and it's going to live in the static data. All of that is going to happen because we put it in the .data section. Now, the interesting part, which we're going to probably be doing more of tomorrow, is that you can use this label to access that variable. You can use this label to access the global variable or maybe change it if you want to. Okay, so let's do it for the array. For the array, this is an array of integers. So I'm going to actually do something very similar. I'm going to say global array, and then I'm going to say dot word, and then I'm going to list the numbers, and I'm going to separate them by spaces. In fact, I can just copy and paste. That's it. That's all that you have to do for global. Imagine for this line, we needed to do all of this. And for this line, we just do this. So for this one, you essentially have to copy all of that and put it here. And that's it. I mean, you can run your code. You can run it, of course. Running it is going to work just fine. And we can look at this data segments, but we don't want to do it for now because I'm actually right now not certain that they use our convention. And you can see that they're not. They're kind of, this is the lower byte, and they're going, like, as you go down, you're increasing the address. So, and that's okay. That's another convention, but we don't want to be looking at this. Maybe there's a way to actually flip it and look at it. But for now, let's just not worry about this. All right. So that's how it is. Now, if you have, let me actually show you just two more examples, and then we can end it. You could potentially say another global without giving it a value. That's allowed, just like you can do it as a local variable. You can actually do it as a global variable. That's fine. And you can create even an array of integers, another global array, which has, say, for example, 10 elements that don't have values yet. That's okay. You will give them values as you execute code here. Of course, this code is not going to change any of that. But if you have global variables and arrays, you must have code that changes it. Otherwise, you don't want to have those variables and arrays. So when you see something that looks like this, you cannot say dot word, because dot word should be followed by the value. So you cannot say, I'm going to do this, and I'm going to say dot word, and I'm going to keep it blank like this. That's not allowed. So in this case, when you have global arrays and global variables that are declared but do not have value or values, you would have to use another directive called dot space. And dot space essentially means just allocate space without values. And following that, you can see it's great. I mean, I like this. It says specify the number of bytes, not the number of words, the number of bytes. So in this case, what would the value be? Can you guess? So I'm going to allocate space for this integer. What do you think the value is going to be here? How many bytes? Not 8, 4. We just want to allocate 4 bytes for the int because our ints are 4 bytes. And for this array, it's the same thing. You have to use dot space. And how many bytes do we need for this one? How many bytes do you need for 10 elements? 40. Yeah, that's good. So you would say that dot space 40. Now, we haven't talked about kind of accessing them, changing them, looping through those. We haven't talked about any of that. We're going to do that soon. Maybe tomorrow if we have time. If not, it'll be the day after. But at least for now, in this short video, you know how to write MIPS code that converts global variables and global arrays into MIPS code. And there's other directives. You can actually, I mean, if I were you, I would just kind of do that and just read some of them. So if you have a short here instead of an int, that would be 2 bytes. And here it would be called half. Instead of a word, it's a half a word. And here you can see it says it's going to allocate 16 bits. And then you can also do byte. That's going to happen for a character. If you kind of declare a character, you can just do byte. Of course, you would have to use, you would always start with the global variable name, always. And after that, you can use .byte for just 4 bytes. You can do half for 16 bytes or 32, word for 32 bits. So word for 32 bits, half for 16 bits. I hope I didn't say 16 bytes. And byte for 1 byte or 8 bits. And when it comes to space, you can just use space. You can do space 1 up to any number you want. So these are really the ones that you need to know. Half, let's say byte, half, word, space. These are the ones that you need. All right. Do you have any last minute questions? All right. It doesn't seem that you have any question. Actually, there is a question. Let's see. Okay. All right, Grace. Thanks for letting us know. Um, so yeah, if you can't do it today, yeah, we'll be having one on Monday. Even though we're gonna have an exam, we're gonna do a session on Monday. So as always, thanks for attending, and I will be posting those videos in a few hours. We're gonna have a quiz tomorrow, and feel free to reach out to me if you have any questions.